I didn't make it beautiful. So yeah.
I didn't have to do the last one in the theory.
Sorry?
The last one in the essay.
What happened to it?
The B, I didn't know how to do that one.
You didn't do it. It says sketch
Yes.
an energy profile. Okay. Okay, sketch an energy profile diagram to show the effect of catalyst on the reaction below. That's between homing. Okay, I guess it will. Let's see. Sorry. All right. Oh, what's this? I'm coming. It's really okay. Number 1D is correct. What's number 2? Which of the following decreases down the group in the periodic table?
B.
Decreases down the group. Really? Are you sure? What did you call it? You said what?
B.
B, correct. Ionization energy. B. Number 3. A finely divided metal form of a metal burns more readily than in air, readily in air than the rod because of the rod has what?
D.
A, high molar mass. B, small surface area. C, protective oxide coating. D, different chemical properties. So what's the answer? Yeah?
D.
D, no, the answer is B, smaller surface area. Remember, when we're talking about rate of chemical reaction, that surface area would make it burn faster than the rod form. So the answer is B. Okay, so you failed that. All right, the next one is number 4. The rate of production of hydrogen gas from the reaction between zinc granules and hydrochloric acid can be increased by what?
C.
Can be increased by using zinc powder instead of zinc granules. Correct. Number 5. Number 5. In the periodic table, the element that loses electron most readily belongs to where? Group what?
A.
A. Correct. A. Correct. Okay, number 6.
C.
You said?
C.
Number 6. Which of the following set of elements are arranged in order of decreasing atomic size? You said C. Atomic size, the size. It's decreasing. Remember decreasing, okay, from high to low. B, C6, N, O. And then you said BE is 4. C, carbon. Um, 4, 6, 7, 8, 8, 7, 6. Atomic size, BE. Decreasing is from highest to the lowest, right?
Yes.
Okay, correct. Number 7. How many orbitals are in the D subshell?
C.
Sorry?
C.
5, correct. Number 8. A catalyst increases the rate of chemical reaction by
B.
decreasing the activation energy, correct. Okay. Number 9. In the periodic table, alkaline earth metals can be found in group what?
D.
D. Group 2, correct. Number 10. The energy required to remove the most loosely bound electron from an atom in gaseous state is known as what?
B.
Ionization energy, correct. Number 11. The rate of reaction usually increases with an increase in the concentration of reactants because
A.
frequency of collision of particles is higher, correct. Number 12. An increase in the rate of a chemical reaction on heating is due to increase in
B.
collision rate. C. Collision rate. Okay, number 13. The activation energy of a reaction can be reduced by
D.
Introducing a suitable catalyst, correct. Number 14. A chemical equilibrium is established when
D.
Correct. That's when concentrations of the reactant and product remains unchanged. Number 15. Element from left to right in a given period of the periodic table shows
C.
Steady increase in atomic number, correct. Number 16. A reaction is said to be at equilibrium if
A.
This is really this is really not a good, it's not really arranged. It's actually meant to be D. It's actually meant to be D. Let's give that for bonus because of the way it's arranged. I don't even like that. Okay, number 17. If X is group 3 element, its oxide will be represented as what?
A.
Sorry?
A.
Correct. Number 18. Which of the following halogen has the lowest electropositivity?
D.
Sorry?
D.
No, it's C. Fluorine. Fluorine is highly electronegative, so is the highest electronegative element in the halogen, so it will also have the lowest electropositivity. Okay, number 19. The rates of chemical reaction of solids are not affected by Are not affected by what?
A.
Are not solids are not affected by pressure. Have you forgotten that?
Oh.
Pressure. I thought the pressure is only for gases, right?
Yes.
Okay. Number 20. Which of the following reactions will be affected by change in pressure at equilibrium?
C.
C. Okay, first, all of them are in, okay. A is not going to be affected by change in pressure because the number of moles are the same and all of them are in gaseous medium. So let's look at C. They are also at equilibrium. It's not going to be affected, right? Do you see that? C will not be affected by change in pressure now, isn't it? Because the number of moles are the same. 2 here, two by the left, 2 by the right, isn't it?
Yes.
So which do you think would be the answer? Though you didn't get that part, though. So which one do you think what do you think would be the answer?
B.
E, D, or B?
B. B.
B, correct. B would be affected because we have 3 here and 2. All right, awesome. Okay, state the periodic law.
The properties of the elements of the periodic table function of their atomic number.
Okay, correct. The properties of elements are the periodic function of their atomic number. Good. Okay, they say use the form of the table below to answer the question. That was, okay, please sum the total. What did you get in for objective?
My chocolate.
Sorry?
What is downstairs? Anyway.
16.
Okay, 16 over 20. Okay, that was a fair one. All right. So that was a fair one. Okay. Now the one you just answered is 1 mark, periodic law. Okay. So what is C? Now they say use the form to answer the question below. The letter representing P block. What are the letters representing P block there?
D and A.
D and A. Correct. Correct. Okay. So let's see the next one, halogen. Which one is which one is
D.
which one is halogen?
D.
D, correct. Element with the lowest number of proton in its atom.
C.
Sorry?
C.
C, correct. Alkaline metals.
C and E.
Sorry?
C and E.
C and A?
E.
Oh, correct, C and E. Noble gas.
A.
A, correct. S block element.
C, E, and B.
Correct. Most stable atom.
A.
Correct. Alkaline earth metal.
B.
Correct. 4 marks. Good. Get your 4 marks. All right. So, state Le Chatelier principle.
If an external constraint such as change in temperature or pressure of concentration is imposed on a system of equilibrium, the equilibrium will shift to annul the constraints.
Okay. Okay. It's all right. Good. The next one is sketch an energy profile diagram to show the effect of catalyst on the reaction below. Okay, now the first thing you should ask yourself is, what kind of reaction is this? What kind of reaction? Is it an exothermic reaction or is it an endothermic reaction?
Exothermic.
Sorry?
Exothermic.
Okay, good. So you are still going to draw this because it's something you can do. Since you didn't do that, but I will still give the guide you on how to do that. That means you got 4 to 7. This is meant to be 10. Okay, good. I said it. Okay, 4 to that's 6, 6, 7, 10. That you can't just allow these 3 marks to go waste like that. So what you would do is I'm going to share my screen. Um, I'll copy this. I'll copy this. Then you have to draw it. Very, very important for us to do that. You know how exothermic reaction is, isn't it? Right? You know, you remember the diagram now when we did that? Can you hear me?
Yes, sir.
Remember the diagram for exothermic reaction, isn't it?
Mm.
Okay, so the energy profile diagram is simple. That's an exothermic reaction, so I'll need you to draw the energy profile diagram.
So I should annotate it or in my
Yes, please do that. Where did you get this drawing? Okay. I now know what you were doing. Are you done?
Yes.
Okay. But look at what they said. They said draw an energy profile diagram to show the effect of catalyst on the reaction. Now, you've already drawn to show the reaction, but you did not show the effect of catalyst. The effect of catalyst here. Remember, yeah, what you did was good, but you didn't show the effect of catalyst. Oh, sorry. You didn't show the effect of catalyst on this, on this. You drew a good diagram, but the effect of catalyst was not clearly stated here. So what you just need to do is this. Let me do that. What you just need to do, oh, correct. When did you do that now? You just did this, right?
Yes.
I was just surprised. I was trying to do something and I just saw it. Wow, just popped in. Then I was like, what happened? Okay. Now what that means exactly what you just did now. It's this is the activation energy with catalyst, but this place is the activation energy from here downward is the activation energy without a catalyst. Why this one here? You just put them activation energy without catalyst at this other side. That's this one here. Why this little one that reduces the activation energy becomes the activation energy with catalyst, right? So you
Yes.
put your reactant. You can put your reactant as N2 plus 3H2, and then your product giving you. Okay, so everything is correct. It's correct, and that's all. All right. So that means well, that's it. Not for yourself. You did well. Come on, clap for yourself now. That's a good one. I'm really, really proud of you on this. Who is there, please?
Question.
Oh, Kosi, help me appreciate her. Clap for her, Kosi. Father, we thank you for today. Thank you for how far you've helped us. Blessed be your holy name. Be thou exalted. Be glorified, O Lord. In Jesus' name.
Amen.
Amen. All right, I'll send the assignment to her right now. All right, thank you.
Okay.